Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Caines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we're very lucky to be joined yet again by Scott Arciszewski. How you doing, Scott?
I'm doing great. How are you, Ed?
I'm very good, thank you, sir. Very good indeed. And I will say sorry and apologise to you already. I know you've just said to me that it is a holiday in the States, and as you know, anyone in the security industry, you know, you're kind of the only one probably awake at this time. I think it's 10 o'clock your time now, so I do apologise, and I'll try to make this podcast as interesting as possible. So how have things been with you since we last spoke? I think we last spoke probably in February or something. So it's been a fair whack of time.
Oh, yeah, it has been a fair work of time. I went to the DEF CON Crypto and Privacy Village earlier, well, I guess last month now. Gave a talk about designing usable cryptography, you know, something that mere mortals, i.e. developers, can use. Most cryptographers, their idea of usable is, okay, well, you know, take this arbitrary byte string here and hope that they don't try to shove a password in it. And you know, oh, well, they should be able to specify what mode they want to use. And, they want to, you know, they're going to have to set their own MAC function instead of just having it hard-coded for them. And then you get, like, this long list of, you know, knobs and levers that developers have to know which one. It's like, oh, don't use these options. They're not really secure. They're just there for legacy software.
And then you think, why are they available? I mean, it's actually that's really funny because, I mean, that is development, software development design, good API design, isn't it, at all layers? And, you know, in the security space, you know, maybe say like in a business domain space, having a bad API, you know, you may get some like, you know, domain concept leakage or, you know, again, it may be a little brittle. But in the security space, if you have a bad API, like you just say, you are in for a whole world of hurt. So it must be really important to nail down these APIs and, you know, to provide them to people who don't really want to know the underlining. They don't need to understand it. You don't want them to understand it because, you know, they probably would do it wrong if they tried to understand it.
Mm-hmm. Libsodium, which landed in 7.2, is based off of SALT, you know, NaCl, Networking Cryptography Library. That was a University of Eindhoven research project. And the entire premise of that was you don't need to know what it's doing. Just use it. And there's some things they could have done to make it a little bit better, but they designed it for C programmers, so they didn't really have that option.
No, that's so interesting, though, because, I mean, I suppose, in as you say, in the space now, still of this cryptography space, security space in general, do you find that the APIs just aren't well equipped for general use consumption, I suppose, and you still need to understand a lot of the primitives, a lot of the fundamentals, and as you say, the levers to get around?
Absolutely. There's some things I don't think we'll be able to get away from people having to understand. You're going to have to understand that cryptography can generally be broken down into, you know, you have something that requires 0 secrets. That'd be like a hash function. It's something where you have one secret. This could be a shared secret, or this could be something that's not shared, that's just local. That'd be something like, you know, local encryption. And then you have something with 2 keys, where each participant in a communication system has a private key or a secret key to keep the first letters for variables separate, and a public key. And that's shared through the network. It can be shared completely publicly. You can blast it all over the radio, and it won't compromise your secret key, assuming the algorithm's secure. And I don't think there's really a way to abstract that away to the point to where nobody will have to know that you either have 0, 1, or 2 keys. I would consider that fact a fundamental to using encryption or cryptography in security. But you shouldn't need to know the difference between like an ARX cipher or a substitution permutation network.
And it all goes over my head. I think I completely agree with you there. That I think that level of abstraction with the 0, 1, or 2 keys and stuff is a fair, you know, abstraction to be on. You know, that's a fundamental abstraction to be on. And how to generate these keys, to generate them securely, you know, the way to use them, etc. Those are the API. Those are the things that can be hidden in a good API, in a secure API, and that can be kind of, you know, moved away from the developer themselves. They just need to understand, yes, this is a shared, you know, secret. This is a public key cryptography, or as you say, yeah, having none whatsoever.
Absolutely. Google recently, a bunch of their engineers wrote a library called Tink, and it was like their answer to libsodium, but it was for like their own internal software. It's used by the Google Play Store, so they had to write it in Java. They use it for their internal servers, so they wrote an implementation in Golang. They recently open sourced it, and I thought it was a great idea because, hey, you have Google engineers led by some of the world's leading cryptanalysis experts like Tai Duong and I'm going to assume Daniel Bleichenbacher is how you pronounce it. It looks like a German last name, and I think he hails from Germany, but I've never actually been told how to pronounce it correctly. Bleichenbacher is the guy who wrote the padding oracle exploit against RSA with PKCS1 v1.5 padding. Like I said, this is one of those things that developers should not really need to know, but most of the SSL attacks that unfolded over the years, the really scary ones like Poodle and Drown, all trace back to his original research. So he's kind of like the father of breaking SSL in that regard.
That is a pretty badass title to have.
Yeah, and they are all worked on Tink, so I'm like, great. So I opened an issue on their GitHub project saying, hey, would you like to support PHP? I intend to follow us up with a pull request. And one of the people I didn't know very well responded, due to some very general security concerns, we will not support PHP, and closed the issue outright.
Oh, well, that's not productive at all. What was there any kind of aftermath to that, or was that it then? Really, they just don't want to support PHP.
I reaffirmed that, or reasserted that this was something that I was planning on doing. If this wasn't something that was going to be a drain on their internal resources. And then I asked, what security, concerns in general? And Tai Duong, the guy who worked on the Beast attack and all the most of the stuff that broke SSL over the past 5 or 6 years, reopened the issue and said, hey, if the community is willing to help, we'd love to support PHP. And then he said, oh, here's what Google's internal resource says about PHP as a language. And he basically said, oh, well, because of its CVE report history over the years, they don't recommend it in their own products. And then they mentioned something about security hardening, and I'm like, your configuration. So I wrote a very long, carefully written post linking to a lot of the blog posts on the Paragon blog, including the one that was configuration-driven security considered harmful. Because when people are like, oh, well, the guide to PHP security is to open your php.ini file, I go, stop. That gets you only 2 or 3 steps past the starting line.
But but one thing, so you mentioned there the CVEs, and you say there's the plethora of them for PHP. The only reason why there are so many CVEs for PHP is the fact that it's such a popular language. Isn't that the reason? I mean, obviously there are security concerns, there were and stuff, and there always will be. But the reason why more and more happen is because more and more people are using it, so more and more people are more likely to want to try and break it. I don't quite understand that idea that the CVEs, I mean, as long as these CVEs are getting addressed, is I suppose the main claim.
Yeah, I can link you to the GitHub issue.
That'd be really great.
But the 2 languages that they mentioned specifically were Go and Java. Now, Java has had more vulnerabilities in its history, lifetime, than PHP. The number's close, but it's larger in Java's department. And in the past year, PHP had 11 vulnerabilities. Most of them were in the EXIF extension. So if you're not processing images, it doesn't really matter to you. But, vulnerabilities nonetheless, 11. Java had 43. So in raw numbers, the one that they were suggesting people switch to had more vulnerabilities than the one that I was asking if they wanted to support. And then Golang had a Sev 9.2, which is a critical bug. And that was higher than any of the ones that Java or PHP had in the past year. So in my post, I basically said, if you slice it in other ways, which are very reasonable, or if you look at the raw numbers, or if you look at the numbers in the past year, Java don't look so good. And if you only look at the most severe one, Golang, takes the prize. So using vulnerabilities, vulnerability statistics as a judge for a language is something that's actually not straightforward.
No, because it's all relative, isn't it? Because you say like the EXIF, if you're not using the EXIF, that reduces, the amount of impact. I know that it still counts towards the number, but the relative, and also you say, the severity of the thing, if that code is being hit by every single PHP instance all the time, then yes, that is far more, worse than maybe a code path like an EXIF that doesn't get used as much.
Yeah. You could have like a critical, this is a, ASLR leaking, ROP chainable, remotely exploitable thing in the PHP engine. It doesn't matter what your script is doing. That would be like, okay, this version of PHP should never be used again. Bury it in the gloves, wear desert kind of like alarm. But I haven't ever heard of anything that bad. Usually it came down to your PHP script has to be doing something really dumb in order for this to actually work. And that's going back as far as when I started getting into security, which was, over a decade ago.
So do you think this is language bias again? I know we've spoken about this before, like with PHP, that, people just don't, maybe from its history or just the fact that they just do not like PHP. So it's, one of the ways they can kind of laugh at it is the fact of its, history with security vulnerabilities.
In the overview, yes, absolutely. But I will say in their defense that at some point in time they had to have evaluated PHP, and it was probably during like the 5.1 era, or if not older. So the cool thing about the language that we work in is things move quickly. The difference between like PHP 5.5 and 7.0 was huge, but between 5.6 and 5.6 and 7.0 was also pretty huge. I mean, you had a lot of neat things come in that weren't in the earlier versions, and a lot of things got cleaned up in the 7.0 change. And then Nikita Popov and a couple other people have been really gunning for deprecating old behaviors and old features,
which is a huge task and a really admirable task. That's like just the work you do. It's those type of things are really helping push the language to keep it modern and keep it moving forward.
Yeah, that's the important thing. It's getting modern, it's moving forward, it's getting faster, it's getting more pleasant to work with. Like 7.3 made here docs and now docs saying if you're working with any kind of version control software, because you can indent the last line of it. I can't tell you how many times I've had to use here docs in a old software project or two that it was just a mess because I had to put the last line on its own line of the doc block, or not the doc block, the here doc or now doc. And it just, when all your code is neatly indented and then you have something that's squished forward to the left.
It's just really horrible, isn't it?
It really is. It makes you not want to use that syntax ever. 7.2 and 7.3 fixes both, I believe, and that's coming out at the end of the year. So when you have an organization that probably at one point gave the language a chance before it made all these, in my opinion, very important changes, they are running on outdated information. So there is a language bias of probably several individuals that work at Google. That's my opinion, obviously. But in their defense, they're probably, they took a look at it once and then they said, okay, well, this is, this kind of stinks. And then they had to move on to other things and they never, updated their understanding. They were proceeding with the basis of, oh, well, what we believed back then it's still true now. If things changed, it's probably not that drastic.
Which is very, very, very wrong to assume that in the PHP world.
Absolutely. So the response to my comment was favorable. They're like, yeah, thank you for the information. And the person I was talking to, Ty, actually said he was going to get the person who maintained that internal resource to comment on the thread, assuming they have cycles. So I'm interested to see if they're going to come at that Google discussion with a bunch of, vile, snarly hatred and, pointed words because they hate the language, or if they're going to come in and go, holy crap, how did I overlook so much change?
Absolutely. And I think this is the thing. And I think what you're doing, where you're just providing the facts now, and, you're doing a really good job in that, people's, you say people, they evaluated it in the past, they've moved on, their evaluation is still, back in that time frame. They haven't got the time, haven't got the cycles to do it. Again, maybe they probably don't want to, they're probably happy with the languages they have, but I suppose no, but in a big company like that, maybe one of your jobs is just a constant, evaluate languages and, these, the continuing design of things and how things are changing. So it can be a little bit kind of blinkered eyes, to kind of totally dismiss a language. Maybe if we rebranded PHP as a new language with a new name, it would probably be a better, in quote, branding exercise and, marketing exercise for it, because people completely, buy it because of the fact of the history.
That's possible. I know a lot of people, PHP 7 was that rebrand for them.
Definitely.
Remember the decade of waiting for Perl 6 to come out?
Oh, yes.
So Perl 6 was like its own thing in most people's minds, separate from the Perl they worked with every day. Something similar happened with PHP.
I was thinking PHP 6 is around that time frame, isn't it?
Yeah. I'm sorry. I'm just remembering a lot of the jokes on the PHP Stack Overflow chat about running PHP 6 in production.
Well, actually, I see some user agents sometimes come in with PHP 6, which I do think is just a nice joke that, someone's decided I'm going to use the user agent to PHP 6.
Oh, that's funny.
And it's like PHP 6.2.4 or something. And I'm like, wow, why did you decide on that version? There was something,
I couldn't tell you. That is pretty funny.
It's so strange. But no, I mean, so actually one thing that rewinding a little bit, we did kind of go into was the concept of CVEs. I think we've kind of glossed over them a little bit. So the CVEs, they stand for common vulnerabilities and exposures. Would you mind for the audience giving a little overview of what these actually are and kind of what what they actually are there for?
The simplest way I can sum them up is a unique identifier for vulnerabilities that it will work across multiple issue trackers. That's pretty much what their point was. How PHP bugs are an increasing integer. Some issue trackers have their own increasing integers, like a ticket ID and track or whatever, an issue in Google. Some of them don't have increasing integers. Some of them have weird, serialized identifiers like SYSV, like 5623C or whatever. There are countless ways to enumerate issues in software management. I'm pretty sure there are consultants who are really pride themselves on coming up with a really unique and clever way of identifying, software issues. CVE was created, I think, 20 years ago. It's an old project to basically coordinate between different companies, different organizations. Whether it was originally designed at its core or not, it became the industry standard way of identifying unique vulnerabilities. So that way, if it's there's this Debian bug with this number, and then there's this Red Hat bug with this number, and there's a PHP bug with this number, and it's about a buffer overflow and blah, blah, blah function. They all have the same CVE, so it's the same vulnerability.
That helps a lot of the cognitive overhead of trying to, mind these all things together.
Exactly. So that's its general purpose. So CVEs get registered a little bit differently than just you submit a form on the internet and bam, your ticket's been created, it's being reviewed, here's your ID number. You have to actually send at least a sentence, the product. You have to list the product, the vendor, any other relevant information like that, versions, and then at least a sentence describing what the vulnerability is, what the bug is. It can be as vague as you want. If you're trying to prevent third-party leakage or unintended disclosure, you can say, hey, there's a sev medium vulnerability in PHP's fast process management, or fast CGI process management, and they would look at it, decide if it's credible or not, and they might ask for more information, and then they'll say, okay. And I usually send them a full disclosure type email, so it has all the technical details, so they know exactly what they're getting into. And they'll say for each vulnerability, they'll say use CVE dash 2018 dash, and then a 4 or 5 digit number for each bug in question. I've reported a security bug that I thought was, there's 2 pieces to it, but it's just really one bug because you need both. And they've responded with, okay, use CVE blah, blah, blah for one and use CVE blah, blah, blah for the other. And I'm like, oh, okay. That's going to make conversations a little awkward, but sure.
So who actually then, like, is this like an open source project? Is this, some company that, takes this role on to kind of, it's a very good thing to do to kind of unify these things. And like you say, trying to juggle between all these different ID, verifications is, working out which is which and stuff. Who actually runs this then?
It's actually done by MITRE, MITRE, which is an organization that also runs the National Vulnerability Database over here in the States. So their entire thing is trying to manage and herd cats the insanity that is, thousands of independent people doing security research and reporting their findings in a way that organizations can find manageable. They do a lot of other stuff too. They have another project that's not CVE but CWE. It's like Common Web Exposures, I believe. And the guy who started CVE, I think, is now on that project. And the goal of that project was to basically classify vulnerabilities, similar to what I suggested in the General Introduction to Application Security article, put things into like a taxonomy view. Because a SQL injection is a SQL injection. That's a specific instance of code data separation breakdown, where you have data being run as code in some way or form, way, shape, or form. CWE is like an attempt to say, okay, well, what kind of mistakes do developers make? Or what kind of systems failures occur in the real world? Instead of just saying, okay, well, there was this really nasty remote memory disclosure in OpenSSL. It's like, oh, that was that was a unvalidated memory read or something, remotely accessible. And then they would have like a CWE for that class of vulnerability rather than that specific instance and that specific product. And the two projects I think are going to work hand in hand is the vision. MITRE runs the project. They have a bunch of other companies that have blocks of CVE numbers. That's why they're not always increasing.
So then they can release them, so it makes it a bit more manageable, distribute it a little bit, the work.
Yeah, I believe Adobe registers like a space of 200 or so every year. So does Microsoft. Just that way, for their own products, they can have their own, okay, well, a vulnerability came in. We need to fix it now. We need an ID. We don't want to wait for MITRE. Okay, we have this block reserved.
Now, that does make a lot of sense, doesn't it? And it kind of is I find it fascinating that, one company could manage that all themselves, especially if they're doing it for free in quotes or, for whatever. It's it's a very good, good kind of project to do. And it is interesting because you can kind of think of it in a positive way that it's helping, open this up to the public. It's saying, hey, this is a vulnerability that we found in this project, this product, people should upgrade, people should fix, etc. But it's almost like the inverse as well, where people could use, and it's interesting when we kind of move on to talk about pen testing and code auditing, but, working out what types of versions and stuff, maybe using like header leakage and stuff, to work out what versions a certain server's using or whatnot, you can then start to pin down, okay, what actual vulnerabilities can I use on this server? Did you find that, there's kind of a double-edged sword to it? I suppose, it's good that it's been opened up, but it also can be the opposite case where you're finding vulnerabilities and exposing it to people who probably wouldn't know that already.
The thing with like reconnaissance work is the efforts done by people to open up InfoSec, like the full disclosure mailing lists, MITRE's CVE project, to help organizations communicate without having to like spend thousands a year on like a exclusive membership. They aren't really going to help or put a damper on most of what goes on in the real world. So some criminals don't even do reconnaissance. They just blast the internet. They'll scan everything. If it's on the internet, they want to know what it is. Like they're like obsessively curious, but it's actually automated. But it's fun to think of it that way. And then you have the people who will use like tools like Shodan.io and just type in like a IP address or a net range and go, oh, well, there's this many interesting targets in the range that's owned by that company, and they'll start from there. So reconnaissance isn't one of those things I do anything particularly fancy with. whenever I do an engagement. I have friends I can lean on, do subcontracting work if I ever needed to, who can do all kinds of crazy stuff like exploit the TCP stack in the router using a custom ARM exploit. But that's them. So normally when I'm looking at something for an actual like black box test, it's in the form of like a website on intranet. So I'll have my laptop, I'll have usually an Ethernet cable or like Wi-Fi credentials, and then there'll be like a host on a server. They'll give me the IP address, and I can usually only find one port, which will be like 80 or 443 if things are happier there. And then it's like, okay, here's our, this is our lab environment. Here's a copy of our software running on a server with dummy data that's either anonymized or just completely faked. Have at it. So the first thing I do is I just open it in a web browser with either tamper data hooked in, or I'll open Burp Suite and use that to read all the data. The first thing you want to remember if you're ever doing recon work is to record everything, because you might miss something. And then I don't just use header leakages. There's some other tricks you can use. Like there's a GUID query string you can append to any PHP server, and it'll respond with an image you can use to fingerprint the version of software it's running.
Oh dear! You see, this is the interesting thing, and I suppose that the first thing in recon is working out versions, isn't it? Working out structure. Is that how is there kind of like a step-by-step guide you go through, kind of like the processes you'll go through, like some automated work that you'll do, or will you kind of all do manual, kind of how it depending on how you feel about that certain application?
It depends on really the rules of engagement. If it's like wide open on the internet, it's like, oh, have at it. It's like, all right, so the first thing I'm going to do is go on shodan.io and literally just plug in the IP addresses and the domain names and see what else they find.
So what is that Shodan then? So is that like an open, kind of directory of all the different domains and all the different services that they've been able to find for that range?
They scan the internet constantly. I think they use servers in Russia to do this, last I heard. And then they basically collate all their findings together. So if you have like an open port on port 80, it'll show up on Shodan and with the header information, like the title of the web page and whatnot, and any other metadata they can get. And I think one of the more recent things that they have is that they actually have an exploit search you can actually tie into it. So if it's like, oh, we're using this version of Apache struts, that means they didn't patch it, which means that it's vulnerable to remote code execution, as affected Equifax last year.
Yes. Oh, yes. And so this actually, tools like that actually then for developers, for people looking into the security of things, trying to make, keep on top, is actually quite a useful thing to keep searching maybe their own IP ranges and seeing what they find of them and that.
Oh, you should absolutely use any of these tools defensively to scan your own systems. Harden your own security, make sure that you're not, if you're leaking information about what software you're running, make sure you're keeping it up to date very rapidly. Don't sit there running like .NET Nuke that's 5 years old and then wonder why you have reverse shells sitting in your uploads directory.
Yeah, absolutely. And it's an interesting one because, I mean, as you say, with, there's lots of different fingerprinting you can do, even based on just the headers coming back and then the order in which they're actually appearing, very similar to, this looks like an Apache one, this looks like an Nginx and stuff. Do you have any like kind of applications that you use for fingerprinting in this kind of thing? Or, is that again a manual process where you're kind of, using bits and bobs of different applications?
I know there's a lot of manual work that can be done. I generally just use Nmap, which is a network scanner. It has built-in OS fingerprinting as part of its scanning functionality. So it'll scan a host and say, this is a Linux host with 100% or 99% confidence. And then it'll say, like, you can break down what their guesses are and how confident it is that it's this particular operating system. And generally it's accurate in the real world because people don't bother with obfuscating what OS they're running, because that's way too much operational overhead to maintain that in the long term. But like if you're testing like a small I would say like a startup project ran by somebody who's very enthusiastic about like forensics work and like really weird blue team techniques that involve messing with the hacker, you will eventually run into a system where it's like, oh, it's actually Linux, but it's advertising itself as Windows.
Is there much value in, as I say, in a defensive way to do things like that? Or is that kind of, not a waste of time, but kind of, you could put your power and your thought in elsewhere?
In my opinion, it's a trade-off. You could do that, and you'd have the advantage of you're always running on a fresh OS. So it's almost like the ideal of like serverless, where it doesn't have to run on your own hardware or your own software. It's just kind of like in the cloud somewhere. You can extract some of the ideas from that and apply it in a security context of, oh, is it running Ubuntu? Is it running Debian? Is it running CentOS? Is it running Windows? Is it running, OS X on a server, which I've not really seen in the real world too much. Who knows? You could either be hiding the fact or you could rapidly be changing them like Microsoft used to do with their website. They might still do that, where they would actually host it on a different OS, like I think it was like every week. And the theory in the community, like the pet theory, was that they kept getting hacked, so they kept rebuilding. But the other theory that we've heard from people who are more mature in the community was, oh no, they did that just to obfuscate what they were actually running.
It is a really interesting. And how do they do that? Is it really I'm going to be using a Windows box and then I'll be using a Linux box or whatnot and a Mac box? Or is there ways of me being able to, with the headers, with the ability with ports and whatnot, kind of the fingerprinting to trick it?
I don't know. I don't have any insider knowledge on that one. I think they actually did switch their OS a lot, though.
That's crazy.
Yeah, so to me, that seems like a lot of operational overhead and more of a chance to screw things up. Whenever I set up a server, I spend like the first couple hours making sure that, SE Linux is being applied, SSH is configured properly, you can't log in as root, you can only use ed25519 key pairs, I've distrusted all the RSA keys. Simple stuff like configuring IP tables to only allow people within your VPN to connect to the SSH port. That's a lot of tedious stuff that requires understanding the tools that the OS provides.
Exactly. And then if you've got the skill set, and then you're going to have to learn and relearn it for every operating system. If you're really doing it at the front layer, changing it every week or whatnot, it's either a lot of automation and a lot of understanding.
Or also a lot more room for error, because what works on Debian, right, might not work on Ubuntu. And it's not because their kernels are different. It's because they have different versions of systemd or whatnot.
You're going to get bit. Absolutely.
Yeah. So I don't think the trade-off is worth it. I think it'd be better to pick a simple, probably boring OS choice, really. I don't think people want to run Puppy Linux on their servers. I don't think people want to do, My Little Unix kernels or Magic or whatever. That's probably not production ready for anything. And I don't think they even provide a networking stack, or if they do, that's an April Fool's Day Unix OS, by the way. Yeah, choose something simple. CentOS, Red Hat, Debian, those are all good choices. Anything super consumer friendly like Linux Mint, I would probably stay away from, just because your server is probably only going to be accessed through an SSH port, not through like a terminal, like a monitor and keyboard. So you don't really need all the fancy GUI stuff. Although I do love the Cinnamon desktop environment.
It's really interesting because, again, going on with kind of the leakage of things in server world and everything, I've been over paranoid. I've been a lot more interested in it recently, just kind of looking into these kind of things, like what things do I leak out in all our server configurations? Also, what things do people leak out in their own server configurations and the server setups and stuff? And I did a little bit of recon work. Like in the football Premier League and the EPL, that all of their teams, all they have their own websites, and they're all owned and managed by each of the different clubs essentially. So there's not one true kind of portal for it. It's all of them have their own servers and their own setups, and it's quite interesting to kind of see how that, I thought, okay, it'd be interesting to go through all these, crawl through them all and see what information I can just find just from the headers. And it was fascinating to see and to find, versions down to the point release of, people, X powered by PHP, the ASP, using ASP.NET and, using these sessions, you can easily work out, with view state and all these things in it. How important is it to hide versions? I mean, is it good at all to publish, that it's, powered by a certain version? Is there any value to it?
Not really. People who have failed to hide what versions of software they're running in the past have historically also been the people who failed to update their software. At the same time, if you're keeping your software up to date and you're staying on top of the latest vulnerabilities, the only thing you really have to worry about are 0 days at that point, because you've patched all the old stuff. And at that point, the information leakage from a version of PHP or Nginx or WordPress or whatever software you're running on the back end isn't really going to be much. It won't hurt you in a way that you weren't already going to be hurt, just because if somebody has a WordPress 0 day and your web page looks like WordPress, even if it's, I don't know, some Python-based framework, they're going to try it anyway because they're not going to lose anything. Worst comes to worst, your security software bans their IP address and they switch to another reverse shell, and that's it. They don't lose anything. The economies on scale are on their side to attack systems. They can get a botnet of 100,000 IP addresses for cheap. So they're not really too worried about burning access to their, to your over the anything publicly accessible over the internet. They're not worried about burning access to that path. There's so many ways to attack. They'll just, this door is closed, I'll just open the other one.
That's it. It's so cheap for them. And so would you say then it is just best to close up shop and just to remove all of these headers, the server headers, any headers in there that get leaked out? I mean, the scary ones are like debug headers and things that, certain things, if you leave them in, configuration, it can get scary what actually gets left.
I do believe it's worth limiting the information that you publish to only know, especially if you're dealing with GDPR compliance or anything. You don't want to leak, the last 10 customers that logged in, or, Nancy and Steve of, you never want to do anything like that. So limiting the amount of information you expose to something that only makes sense, don't leak anything that could compromise your users. Don't leak anything that could explicitly compromise your server. That's a good thing to do, but I also wouldn't say, don't spend too much time on it. Don't sit there and go, well, I want to tweak the order my headers come in so where it's standardized and doesn't reveal that I'm running this version of Apache. Don't. It won't matter. The people who are going to attack your server aren't going to rely on that signal. They're just going to go, oh, okay, they're running Apache. I don't know what version, but hey, I have an Apache vulnerability that only got fixed recently. I'm going to try it.
Try it. That's it. So you'd say then recommend, to a degree kind of to hide these things. But also, I mean, the main thing is to keep up on top of updates is really the key thing. Doing any of this kind of, hiding doesn't stop you from having to be completely on top of your updates. This is, a kind of a plus, that, to kind of do this hiding. And you'd also say then using these that website that you mentioned, the ability to have these databases that are searching the internet, just interesting to see what, kind of they find about of yours and any signals that you think, hang on a minute, that kind of leak, came through. Is there any other tools and stuff that you would recommend to be running on a frequent basis to defend?
So if you have a vulnerability scanner like Nessus that you've already purchased, definitely fire that at your server and pay attention to the info section, not just the high, medium, and low, because they'll actually mention a lot of server information leaks in those reports. For anything that you want to test yourself, Burp Suite is probably the industry standard for web application testing, just for doing recon work.
So what is Burp Suite then?
They can call it a web vulnerability scanner. It basically intercepts your network traffic when you're visiting a web page, and then you can actually build in scheduled scans and stuff like that too. And it will actually go, oh, well, this looks like, you have these parameters that you can send data to, either get or post or whatever. And you can actually do automated SQL injection from it and stuff like that. I just use it to collect information and go, ooh, there's a form field here I didn't notice. Let's see what happens if I try to drop a shell command in it. Stuff like that.
That's really interesting. And indeed, you see, these are all tools, as you say, on the pen test side, someone coming in, I mean, it's probably being good to be proactive as a developer, as someone to defend, to use these tools on your systems, on your dev environment, if you want, on your production environment, if you trust yourself, to kind of see what happens. I know there's like the Fiddler and stuff that's in the Windows world, and then Charles Proxy that's in the Mac world. And it's very interesting, I found as well, to see what gets, transferred through the wire.
Yeah, and OWASP has their own called ZAP. Stands for like Z Attack Proxy. So here's a cheap trick you can do to leak information from a lot of websites because they don't turn error reporting off. Find a form somewhere, like if it's like shop.php category equals whatever, and you're not going to fuzz with the value. You're not going to change it from an integer to a string or try to do SQL injection. All you need to do is go to before the equals, type a 2 square brackets, open and a close, and press enter. What this does is it changes it from like a string category equals 10 and turns it to category equals array with the first element being 10. I'm not kidding. I have gotten full path disclosures, stack traces, you name it, from this in the real world. So if you're trying to test your own software, instead of just, I can't SQL inject it. Okay, well, what happens if you do this? Do you leak the file information? Oh, you're not stored in var www. You're stored in /opt/ some obscure file path. So maybe that LFI exploit we were trying a while ago doesn't work because I'm 10 layers down, not 3.
And then you can just readjust. That's fascinating. I think these things are so valuable, and I'm guessing then to automate these is probably the true value, because then you can have these running on a weekly or whatever basis on these stacks. So when you're trying to to constantly keep yourself so nothing slips through the cracks.
Mm-hmm. Yeah, I think so a lot of the work that goes into automation is unfortunately behind products like Nessus or some of these other corporate vulnerability scanners where they, bill per host and all that. The cool thing about automation is that you can do it in a schedule and you don't have to sit there at the keyboard and type in all the stuff. But the downside is a lot of the advanced research that goes into it for things like adaptive scanning, to where if you change your website and you add a new feature, the scanner will automatically go, oh, hey, look, there's a new field here. Let's fuzz this. Let's throw some random ass data and see what we get. If you're setting it up yourself, you might not benefit from that. So that's one thing to watch out for. If you have it's kind of like unit testing. If you add a new feature and don't add a unit test, chances are something's breaking. That's why most people say test first and then write the code.
I think, as you say, there's pros and cons to the automation of it, and keeping an eye on it, making sure you adapt it as you should, and as things change in your environment. But it really is a valuable thing to kind of keep atop of, because I just think I don't think we, as developers, coming from a developer mindset, we don't really think of this stuff. We kind of just set it up once. If we do care about it, we'll think about it once, and we'll just let it go. And as you say, as features change, as products change, as things get bigger, as you remove things, add things, you may not spend the time as you did that one time to configure it to ensure you're secure and stuff. It's good to have these tools to help you have these signals to be able to go, maybe I should look into this again because, this has come up with something.
Absolutely.
And so another thing, actually, and this is kind of moving on to some cryptography stuff, you released a really interesting article called How and Why Developers Use Asymmetric or Public Key Cryptography in the Real World, in real-world applications. I'm just wondering kind of what sparked you, to write this? Was it actually, you, through your presentation and stuff that you'd done recently then?
This was actually something I wanted to write months ago when NIST announced their round 1 candidates for their post-quantum cryptography competition. So real quick, public key cryptography, which is the one where each participant has 2 keys, they each use a type of algorithm. It relies on something called a trapdoor function, where it's easy to compute from A to B, but going from B to A is like computationally infeasible. We're talking like if you had the entire surface area of the Earth converting electricity from the sun, from solar radiation perfectly into bit flips and calculating in a perfect distribution, it would take thousands of years to crack a single key. Like that level of
We like those numbers.
Yeah. So a quantum computer throws a wrench in all that. All the algorithms we're relying on today, RSA, Diffie-Hellman, elliptic curve Diffie-Hellman, elliptic curve digital signature algorithms, they're all broken. The attack complexity goes from 2 to the 100 power to 2 to the 30 in an instant. So quantum computers don't exist yet. These are algorithms that will work once we have a practical quantum computer, and it's not like, oh well, now this is a magic box and it just solves all the problems. It's you have to
the game's changed.
Yeah, you have to build it a specific way. You have to have enough gates. You have to have enough memory. It's not going to be okay, ready, set, go, now everything's doomed. But anything we are encrypting or signing now might one day get broken by a quantum computer in the future if the data is intercepted.
How much are you investing into looking into quantum computing at this time?
That's more of a question of my free time than it is of my work time. So not as much as I probably should. However, post-quantum cryptography is kind of supposed to be the answer to this. So information we're encrypting now with our public key cryptography is very likely to get broken when a quantum computer does exist. So the interest is to have a post-quantum algorithms ready long before then, so we can have some information that stays secret when a quantum computer does come around. And there's no guarantee that one will get built either. Like, it could turn out that there's some property of quantum physics we discover that makes it to where you can build a quantum computer, but you can only get up to like 1,000 qubits, and then suddenly it falls apart. Like, you can't do more than that or something. We don't know yet. We're kind of reaching new territory of physics and technology. But we're assuming, taking the conservative risk on this, that it's going to happen. So a bunch of researchers published their own designs for public key cryptography using algorithms that quantum computers cannot break. Most of them use what are called lattice structures. Think like, do you remember back in school when you had those matrices you had to solve? Picture those, but with thousands of elements, and you've got your lattice-based crypto systems. They usually draw them as like a two-dimensional lattice, but they're actually hyperdimensional. Like, the hard problem there is called the shortest vector problem. They add randomized error. There's a lot of cool stuff they're doing, but at the end of the day, a lot of it's like the learning with error algorithms only work in online systems. So for TLS, the current designs for post-quantum cryptography are great because most systems are online, and you can send a message and it can respond saying, "Hey, that had an error." Learning with error-based lattice crypto systems all have a chance of erroring out. Like, it's 2 to the negative 64 probability, so it's almost dismissible, but it can still happen. So when they published their candidates, and by the way, like 10% of them were broken like the first day. Like, it was insane.
This must be really interesting for you to kind of, watch this kind of, unfold.
Oh, it is. But I was looking through them from the developer's perspective, because I don't expect most developers to understand, any of the math involved, multivariate crypto systems and all that. And it wouldn't be fair because it's not part of the job description. But since I work with developers mostly, I wanted to, I put myself in the mindset, I want to build software using these features. And I'm assuming somebody like Frank Dennis comes along and packages it in a usable library, or maybe Google comes along and, Tink 2.0, uses like Sphinx for signatures or whatnot. And I'm like, with this premise in mind, I'm going to look at these algorithms and see which ones could actually be used. And it was like a 2 of them that I looked at, and I'm like, oh, this would actually work in an offline situation. So I sent an email to NIST, and I think it got disregarded. So yeah, that was what led to that blog post. Was I felt that cryptographers don't understand what developers use cryptography for at all. Like that Google Tink issue where they were just like, if you read the issue, it's very clear that they don't work with PHP in their day-to-day, which is fine because they're cryptanalysis experts. They're not web developers. But their internal resource was blind to it that they were relying on to answer questions, and they themselves had no personal experience with it. There's a lot of layers of separation between cryptography and cryptanalysis experts and your line of business web developers. So developers don't really understand cryptography in general. Some of you do, and that's wonderful. Cryptographers don't generally understand what developers do in general. There's some of them that do, and that's wonderful. And I kind of wanted to address both at the same time, just to give developers an idea of what's coming with post-quantum cryptography, and to give cryptographers an idea on, hey, if you build it this way, people won't be able to use it. If they won't be able to use it, they're going to roll their own. And they're not cryptographers, so they're rolling.
You don't want that.
It's going to end in disaster. And that was kind of the point of the entire post.
No, it was a really interesting post, and yeah, completely admirable. Again, I think bridging the gap it's funny because you can kind of think of it from a developer's perspective to talking to a client, even where it's the same relationship. The developer is the client, and you've got this domain expert, this very intelligent person, the crypto guy, and we've got the same relationship as a client. We've got to try and work with the client to get, and to make them understand as much as they can and stuff, and what they need to understand. So you provide a good API with it, a good understanding of, the problem you're trying to solve. And yeah, it's very, relatable to that, kind of relationship with us developers and crypto people who definitely know know all of the ins and outs. But at the end of the day, the people who are actually going to be using this stuff, and probably causing more damage than good if it's not been kind of shown or taught in the right way, are the developers.
A lot of cryptographer, well, not like cryptographers, but people on the mailing list to standardize cryptography tend to blame developers when things go wrong. There was a discussion about JSON Web Tokens on Hacker News, and they're like, oh, well, JSON Web Tokens has never been vulnerable, and I linked to 2 of the critical vulnerabilities, and they're like, oh, that was in specific implementations. And it's like, no, that's the result of an error-prone standard. We need to fix the standard. We need to get a better standard that people can use, and instead of just saying, oh, well, they didn't do it right. Well, you made it possible to not do it right in the common case, to where one of the vulnerabilities affected half the implementations. So when it comes to those situations, if developers keep making mistakes, I blame the cryptographer. And that's not an uncontroversial position. People don't agree with me on that in a lot of situations. But I think it's the right one if you want to actually have a more secure internet.
Well, the cryptographers are the people who are going to be developing these things. So you either adjust to work out, okay, how is a developer going to use this? How can I provide? Again, it's the API design, thing. It's making an API design in any facet of life that will, make the things that you want it to do work and not allow you to do things that you shouldn't do. So if you're going to have all these knobs and levers and these ways of doing things, someone is going to break it unless you explicitly have good standards, good defined lines, good, defined API, boundaries and stuff that make it impossible for people to do that.
Mm-hmm. And if there's things people are going to want to do, people are going to want to just type their password in as the key because they think it's super, oh, my password is the secret. It's how you unlock stuff. But if you accept an arbitrary string in the password field, or sorry, in the key field, instead of an object that has a specific, derived from password and salt API, people are just going to find a way to dump their password in somewhere. So designing APIs to explicitly address that tendency in a way that still manages to be secure takes a little bit of creative thinking. That is not only just creative thinking, it takes social thinking. You have to understand how people are. And in order to understand how people are, you have to talk to them. You have to talk with them and get an idea. And if your career, sends you off to far into the mathematics to the point to where nobody's really talking to you, it's completely understandable why they don't know, what a Node.js developer is doing with their RSA implementation. They're just interested in that RSA is secure against these attacks, and they don't realize that these developers are going to implement situations that make them vulnerable to attacks that it's not secure against. Bridging the gap between them isn't something that anybody can do alone. I can't just sit there and say, "Hey, cryptographers, talk to web devs, learn that."
And web devs talk to cryptographers. Come on, we're all friends.
It's going to require a lot more effort from organizations like NIST that are supposed to standardize to actually listen to what developers actually use. So some of the things people use cryptography for, you have digital signatures. That's pretty universal. You sign a message, somebody else verifies it. Oh, everything works out. Cool. You can trust the message that it came from that public key, which is usually associated with that identity. So everything checks out. You're good. Then you have things like, TLS. Your public key cryptography is how you're able to communicate with websites and nobody but the server you're talking to can read it, in theory. Metal boxes kind of make that a little bit blurry. But if you don't have a network side man in the middle for your security appliance or your firewall or whatever, generally speaking, the server is the only one that can see what you're saying until it hits the server, and then the server can do whatever it wants with it because you can't ever trust the server. But then you have the third use case, which is the one that's completely being ignored, and that's what I call a ceiling API, and what a lot of cryptography libraries call a ceiling API, which is offline public key encryption. So the idea here is that you'd hit the server with your credit card number, right? And the credit card number is encrypted with like an RSA public key or an elliptic curve Diffie-Hellman key pair, like a one-time one against a static. And, they would do the key exchange, and then you'd have a one-time symmetric key, and then it would encrypt the credit card number. The implementation doesn't really matter. The idea is that you have a public key, you have your message, you encrypt it, and now only the person who has the associated secret key can decrypt it. But the associated secret key is not connected to the internet. It's stored offline. So if you needed to charge a credit card number, like with one of those offline keypads, in order to do like a recurring transaction, like somebody said, "Oh, I want to purchase this," it would just notify the person of the keypad, "Okay, well, 6723 being billed to this credit card number on file for this user," and they would go in there and type it in manually. And the secret key would never be touching a internet-connected computer.
You've got that air gap, haven't you, that I know you mentioned quite a bit?
Yeah. So the air gap helps with security. It isn't like a perfect panacea. You still have to test everything. You still have to keep as much up to date as you can. But the idea is that you can encrypt information online on the fly and then decrypt it only when you need it. And the people, if somebody's listening on the server, they can get the information before it's encrypted, but they can't look at all the ciphertexts and go, "Okay, well, I'm going to decrypt them," because if you were just using AES or Libsodium's secret box function, you would only be able to, if you use those, if you can encrypt it, you can decrypt it. You don't have that separation. It's not built in. You have to have like a public key cryptography component. And if you remember what I said about like the lattice systems that have been proposed, they only work online because of that chance of failure, the error probability. So you can encrypt the message.
Very much rules this lovely option we have out.
Yep. So you could sit there and say, "Oh, well, I'll just encrypt this message." Okay, now you have a 2 in negative 64 chance that it'll come out as garbled and nobody will be able to decrypt the information. So you would say, "Okay, well, I'll just encrypt it twice." Now you're
still playing you're still rolling the dice, aren't you?
Yeah, then it's like, okay, well, the probability goes down to the point to where it's almost trivial if you do like 3 or 4 of them. But now your ciphertext is enormous. And the ciphertext for public key cryptography for post-quantum security are already pretty enormous. Michaelis public key, I think, is like 1.1 megabytes. Yeah. It's an ongoing research field. I suspect that things will get faster and more secure and better designed as time goes on, but there's no guarantee that they will. This is just like, I guess you could say it's like a theory or like a hunch. Just because I've seen some of the optimizations on Sphinx, which is a hash-based digital signature. First you had Sphinx, which was an improvement over something called XMSS, which used basically Merkle trees and hash functions to generate signatures that could be used for one-time messages. They had like a 1 kilobyte private key and like a 41 kilobyte message or something like that. It was pretty ridiculous. So then you had Gravity Sphinx and Sphinx Plus, which came out as part of the competition entries. and they managed to use different techniques to trim down on the public key or the signature size. And as time goes on, it's like, okay, well, this will probably get a little bit smaller. This will probably get a little bit faster. And the security trade-offs will probably be a little bit better, but it's still going to be bigger than, the 64 bits we're used to today, or 64 bytes, excuse me. Like in an N25519 signature, it's 32 bytes and then 32 bytes. One of them is a nonce that's derived from the message.
Man, that's a crazy interesting field, though. So interesting. It must be fascinating to kind of be in this space and being able to like kind of see it unfold.
Oh, it is. So as the NIST competition unfolds and as more stuff goes on with them, we'll probably see new attacks come out that will break existing and new like protocol designs. Some of the papers that come out are hilarious, but you have to understand the reference. So unfortunately, like I can't really name drop any of them here, but one of them, give you an example. There was one called HILA5, one of the algorithm entries, and then somebody wrote a paper where they broke one of the security properties of it, and it basically, in I think Swedish or Finnish, it translates to too bad, so sorry, and they used it as like the word Hellas or Hella or however it's pronounced in the title of their paper. They just typed it, they dropped in the algorithm in place of it. I'm just like, okay, they're throwing puns around based on the algorithm name in their attack paper. So this is...
Oh, brilliant.
I mean, you have to understand a lot of advanced topics to actually really understand what the paper is doing. But the fact that they're doing that, it's like, it's not really cheap entertainment. It's like really obscure entertainment.
We've all got to get our laugh somewhere, haven't we? And in a field like this, which is so hard and so complex and stressful and stuff, you just need to find it somewhere.
Yeah, definitely.
That's awesome, man. Moving on then, actually. So, typically, and, again, talking more about the cryptography, the secrets and stuff, you were in a really interesting panel recently on the PHP Roundtable, and you discussed application secrets. And I think this is another thing where it bridges the gap between, cryptography, what's good in cryptography, and what application and what developers actually do and what they should do. What then, firstly, what is an application secret? What can we define an application secret as?
In general, an application secret's a secret. The application needs to function. This will be like a mail server password, a database password, a local encryption key, something in that genre. It's typically something that is only on one server. You don't want it in version control, and you don't want it to be publicly accessible. So if you have, your RDS instance, if you're on Amazon, or your local Postgres database, and your password and all that other information is publicly readable, and your network isn't really architected to keep it firewalled off from the public, you just lost all your customer data. They didn't even need to hack your server.
Not at all. And that's the interesting thing. There's plenty of things around that. And you did mention there not to store it in your version control system. That's one of the first gotchas. So then what do you do? How can you fathom to kind of store it somewhere then? There's a couple of options that you can see where it's like adding placeholders, so using third-party tools. There's a couple of really good products, like HashiCorp's Vault or AWS Secrets Manager, or the idea would be to encrypt the values. So where do you lean on that? What kind of encrypt the? So when I mean encrypt the values, I mean encrypt them and then store the encrypted ciphertext in the actual version control system. So, and then you've obviously got the decipher key, the ability to decrypt it when you need it on that instance, that server. Where do you kind of err on this? What's your opinion on these two different approaches?
This is where we get into trade-off land, where different operational configurations will favor certain strategies, and other strategies will just be completely a bad idea. So if you're storing ciphertext in version control, that solves 90% of the problem. The rest of the problem is that now you have to have a key in production, which kind of defeats the purpose of having the configuration stored in version control in the first place. And then on top of that, how do you store the key, and how do you decrypt it, and how do you update configuration values if that key is only on the server and not with the developer? So then you have to pass keys around, and people will leave them on their developer machines, and then they'll leave their laptop in the laundromat, and then your security strategy just completely got defeated. So it's not a great strategy. You have the idea of, okay, well, we need to containerize everything, so we need to load everything into .env files, pass it as environment variables. There's not great side effects of this too, because your env superglobal is, it can be leaked out through error pages and all that.
Very easy, and that's the scary thing with environment variables, isn't it? That they're available everywhere.
Mm-hmm. And then you can get into the weeds on this topic really easily. Chris Cornut, who maintains the PHP securing PHP mailing lists and a bunch of other projects trying to get developers more aware of security best practices, published a blog post on phpsecurity.org, I want to say, basically describing how to have encrypted secrets without storing in version control. It's just like for it's encrypted env. Encrypted.env was the strategy I believe he employed, where you could pass your ciphertext through to your containers, and then your key would be stored in a different location on the file system, far outside of your public document root. That's important, by the way. I know old frameworks like CodeIgniter and WordPress, everything was in, you had your index.php in your root file of your project directory. You probably don't want to do that. You want to have like a public directory and set your web server to point there.
Oh, yes. Gone are the days of doing a HC access on every single folder to make sure that nothing else gets accessed directly.
Yeah, we went back and forth on a lot of the different trade-offs. So if you need to do something really trivial, you don't have like any kind of crazy containerization requirements. You don't have an Amazon account, so you're not going to use their secret sharing or key management services, and you just want to have something that stores your encryption keys in a way that only the server can read. Make a PHP file and make it return either an array of strings or an array of objects or whatever, and then just say this arrow config equals include that file path, and that file path is never checked into version control, and then you're done. The idea of using a PHP file instead of like a JSON file is, if somebody manages to trick your server into serving it up as a PHP file, it's just going to return empty. Well, it's going to white screen on them. If it's a JSON file, they'll actually read the contents. And that's a subtle difference that I think most people don't consider when they're designing these systems.
I think it's a really useful difference, as you say, because you're thinking then of the next layer. It's it's security, it's the onion architecture, isn't it? Of kind of peeling back. Okay, they may have been able to attack this, but they won't be able to get the actual secrets because of the fact that we've used the PHP extension instead. Oh, no, I really agree with that. Yeah, absolutely. And it is interesting because, you mentioned there, so because I've read those articles and they're really, really interesting. And I think, as you say, it's a world of trade-offs. There's the options of, secrets fetching. When do you fetch them? At runtime, at bootstrap time. So, you do a deploy, and while you do a deploy and you're bootstrapping the application, maybe, building the cache and stuff, do you fetch the secrets then? So, that you've got them available then in the containers or whatever, containers in the sense of like, say, a Symfony World container, DI container or something, and you've got them available so that, once people start hitting that site, it's plain text then, it's plain text on the actual application, on the server itself, and it's got the secret then? Or do you do it in the case of runtime? So every time someone accesses this page, we're going to have to go and maybe call AWS Secrets Manager or call the Vault or whatever, you're using. It's a very interesting, kind of thing there where Bootstrap kind of storing then the unencrypted value, or always fetching and having that kind of, layer of always trying to call an API.
Yeah, that's one of the trade-offs that, unfortunately, I don't have a good answer to. Sometimes there's arguments in favor of loading it all at once because of simplicity's sake, having a easy application to reason about. There's performance considerations as well. If you're deriving keys from like environment variables instead of just storing the key directly, like you have like a 3-part key, or you're using something in the back end like Shamir secret sharing, people can get really inventive. You're going to want to only do that once. But if it's, for example, you're just using something simple and boring like AES, or using like HashiCorp's Vault, and you can opportunistically only load the stuff you need at runtime without it affecting performance, that's better from a security perspective, because if something crashes and your data leaks, like it pukes, the server superglobal or the env superglobal, or it discloses arbitrary process memory, you want less to be available to be exposed in those situations. So people always, security is in many ways understanding how systems fail rather than how they work. And I think that's what is one of the biggest divides between security people and developers. Developers are interested in what works and how to make it work, and okay, it's not working. Why isn't it working? And hackers and security experts are more like, okay, how's it going to fail?
Yeah, how am I going to break this?
Yeah,
I like that. That's a very true. It's a very yin to the yang there.
Yeah, absolutely. So both of them are useful. They complement each other well, but if you take nothing else away from me talking for an hour or so, it's think about how systems fail and you'll probably do security right.
I like that. That will definitely be the title of this episode. The last thing I would like to mention, I think this kind of bridges the gap between this asymmetric cryptography and then the secrets management stuff. Currently, at my builder, we invested a bit of time into doing this and to looking into the best way we could think of to store these secrets. And we devised an option, an idea. So the idea was that you'd use asymmetric encryption. So you'd have a couple of public keys. You'd have a public key for production, you'd have key pairs, for production, development, and staging. And all of the public keys would be stored in the version control along with the ciphertext. So if you ever then wanted to encrypt value, the developer would be able to encrypt this value, store it because they've got the public key, store it, the cipher in with the version control. So obviously that there is, you are then doing that, kind of sin of storing a ciphertext with the value. The magic comes though when you want the private key. So when you did the deploy, we use AWS Secrets Manager in our case, where that would then invoke. And while you're doing the deploy, so we invested and used the actual bootstrap, the bootstrap time option, where when you did deploy, it would then pull the private key using AWS Secrets Manager. So it's heavily audited and stuff to then do the actual decryption for that particular environment that you're in. So then in that case, then the private key would only be ever stored in Secrets Manager, accessed through audited, ways to the actual box. Now, I know that again brings up the bootstrap problem where, you're storing these things unencrypted. I'm just interested to see what do you make of that option of using asymmetric encryption in this way, and obviously, how we're storing secrets.
That sounds very similar to what Travis CI does with their, their encrypted configuration options. So it's not something insane. It's not without precedent.
Awesome. But I say thank you, Scott, thank you so much again, man, for coming on the show. It's always interesting talking to you about all the security stuff and, kind of helping bridge the gap. I think bridging the gap between cryptographers and developers is a very admirable task that you do, and a very hard task because, there is a massive air gap, as you would say, between the two of us.
Hey, I'm always happy to help.
Awesome. All right then, Scott. Well, I hope you have a great day. And audience, we shall speak to you again soon. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.